secure knowledge. Right. Part 3. Sorry, question 3. Question 3. You are asked to find the mass of a piece of rock of irregular shape having a mass of the order of 60 grams by performing the experiment which uses the principle of movements. You are provided with only the following items to carry out the experiment. A weight of mass equals to 50 grams, right? A meter ruler, knife edge, and a suitable wooden block, right? Pieces of thread, right? Then first one, as the first step of the experiment, you are asked to balance the meter ruler on the knife edge. What is the purpose of the step? Right, balancing this. What is the purpose of the step? Purpose of the step is, right, otherwise the weight of the meter ruler is also come into calculation. Then our purpose is identifying the center of gravity of meter ruler. When center of gravity is identified, right, when the meter ruler is balanced by the center of gravity like this, right, then for our force movement, when it is balanced like this, for our force movement, there's no impact from the weight. There's no impact from the weight of the meter ruler like this. No impact of the weight of the meter ruler. Then purpose is identifying the center of gravity to avoid it from force movements. Identifying center of gravity of meter ruler to omit it. What happens? To omit it from force movements. Right. Give me 1 second. Okay. To omit it from force movements. Right. B. Draw a diagram of the arranged experimental setup on the table shown below. For the balance situation, just before you take a reading, mark the balance lengths L1, L2 correctly. Take the larger balance length as L1. Right. Then measure from the balance point in the diagram. Okay. Then do we have any idea about the mass of the 60 grams? No, mass of the stone around 60. Mass of the stone is around 60. Right. Mass of the stone is around 60. Then that is a point you need to consider when you draw this. Right. Now knife edge is given. Then knife edge should be placed, and a block of mass was given. A block of suitable wooden block is given. This should be kept on the block, right? This is the block, should be kept on the block, right? And pieces of thread are given. Then it should be suspended. Only suspension is acceptable. Should be suspended, right? This is our capital M, and this is the regular mass. This given regular mass, right? That is simple M. And higher the mass, lesser the equilibrium length, no, in a force movement. Higher the mass, lesser the length. Then lesser length is mark. That's important. Then lesser length is, it says, take the larger balance length as L1. Larger balance length should be with the smaller mass, right? Then L1 should be here, right? And L2 should be here. So likewise, it will be marked properly. Otherwise, if you have switched L1, L2, no marks, right? If you have switched L1, L2, right, with a mistake, no marks. Right, part 3. Write down an expression for L2 in terms of simple M, capital M, and L1. Write down an expression for L2 in terms of simple M, capital M, and L1. When the system is balanced, right? Then write the force moment about this point. Say G. Add the force moment about point G. Force movement about point G, right? Leftward force movement is due to capital Mg, no? Then Mg L2. Rightwards means clockwise. Clockwise is due to simple Mg L1. G cancels, right? Then capital M L1 equals simple M L2. Write down an expression for L2. Then subject L2. L2 is capital M L1 over simple M. Capital M L1 over simple M, right? For L2, no? Then capital I have switched the terms. Capital M L2, ne? Sorry. Then capital M L2, right? Method in capital M L2. Capital M L2 equals simple M L1. Then subject L2. Simple M L1 over capital M. Final answer. And even if you write it at once, totally fine. Totally fine, right? I'm writing these equations and the logic, everything, to you to understand. That's what, right? That's what, and that's why, right? Otherwise, when you are writing, no need to mention this much of steps, right? This is an explanation, no? That's why it's a review. You are supposed to draw a graph in the experiment. What position of the meter ruler would you place on the knife edge every time when you take the different set of readings for L1 and L2? Always center of gravity, right? Always center of gravity. This position on center of gravity. We are keeping the knife edge on center of gravity. On center of gravity, because otherwise always that force movement comes. Otherwise always that force movement comes from mg. Mg means weight of the meter ruler, right? E. Suppose you have plotted a graph as shown in figure 1 to find the mass capital M, right? Now, in this method, right? In this method, the reason to go for a graphical method, even when we have the opportunity, we have the chance to just do this by a calculation, is to get a more accuracy. Always graphical methods are more accurate, because usually we are taking like 6 readings, right? Then even if you made a small error, these errors are generalized when it comes to graphical methods, right? That's the reason. Otherwise, when capital M is known, when simple M is known and L1 and L2 are known, right? Just by a single calculation, you can find capital M, but we don't do it, right? We don't do it because the error is high, right? Sometimes those things can be questioned, right? Even though L1, L2 and simple M are known, right? Why don't we do a calculation? And why are we going to a complex method like a graph, right? Reason is accuracy, more accuracy. Errors are generalized, right? Suppose you have plotted a graph, right? Okay. Then first one, in the experiment, you have been asked not to take readings for small values of L1 and L2. What is the reason for this? Right? Small values can very straightforward, because it has a higher percentage error or higher fractional error, right? Higher percentage error or higher fractional error. Then the experiment you ask not to take small readings, then because it has higher percentage error or fractional error, right? What is the reason for this? To minimize, right? So rapi lesson liyan reason ne hal din to minimize to minimize percentage errors or fractional errors in length readings. Right? Part 2. By selecting the two most suitable points on the graph, calculate the gradient of the graph given in figure 1. The 2 points selected should be clearly marked on the graph using arrows, right? Using arrows. Now they are asked to mark it using arrows. So as I told you before, right? Now you have to select two best points, right? You have to select two best points, right? Then what about this? See, this one is very clear, no? Right? Mega zoom karat pera. This one is a clear intersection. This one is a clear intersection, right? Then what's the point? This is 10, no? Then 15, 16, 16, and from this side 10, 11, 12, 13. One point is 16, 13, right? Then again, check for another point, check for another point, check for another point. What about this? See, this one, it's a clear intersection, no? From X, that is 39. From here, 31, 39, 31. Likewise, have two clear points and mark it clearly. Clear points means always, right? It should be an exact intersection like this, an exact intersection like this, exact intersection of the grid. Right now, they are marked and you have to find the gradient. By selecting two suitable points, calculate the gradient, right? Then gradient is delta y over delta x, right? Delta y. My points were, right, 39, 31, 13, then 31 minus 13. 31 minus 13, right? Check the units also, right? Now both are in meters, no? Then no need to worry that much about meters and 10 to the minus 2, 10 to the minus 2 meters. Then no need to worry that much about that 10 to the power and the unit, because both are going to cancel 10 to the power minus 2 with the unit. Then 31 minus 13 over delta x, 31 minus 13, delta x is 39 minus 16. 39 minus 16, 10 to the powers are cancelled, right? Then no need to worry. This is 13 means 23, 18, right? 39, 16 means 26, 36, 23, right? 23. Then 18 no 23, right? 18 no 23 is 0.78. 0.78, right? So likewise, just find it out, right? Find it out. Then calculate the mass m of the piece of rock in kilograms. Mass in kilograms, right? Then to find the mass, we know, see, graph is plotted between L2 and L1, no? What is our equation? L2 is simple m, L1 no capital M. Our equation is this, see, L2 equals simple m, right? L1 over capital M, simple M L1 over capital M, right? Now gradient is simple M over capital M. Gradient of the graph is simple M over capital M, right? Gradient of the graph L2 over L1, simple M over capital M, right? Then gradient equals gradient, right? Say M dash equals simple M over capital M. Gradient is 0.78, no? Gradient is 0.78. Gradient is 0.78, right? Simple M was given 50 grams. Simple M was 50 grams. Then 50 10 to the minus 3 kilograms selling all the capital M, right? Then simplify. Capital M equals uh, 50 times 10 to the minus 3 over 0.78. 50 times 10 to the minus 3 over 0.78. That is 6.41. 6.41 10 to the minus 2 in kilograms. 6.41 10 to the minus 2 in kilograms, right? A small simplification. F. You are also asked to find the mass m naught of the meter ruler using only the other items provided above, except the piece of rock. Only the other items except the piece of rock. Draw a suitable diagram of an experimental setup that could be used for the situation in the space given below. The center of gravity of the meter ruler must be clearly labeled as G. Okay. Right. Now, only simple M. asked to find the mass m0 of meter ruler, right? Only simple m is given, right? No rock. Then we had the previous setup like this, no? Right, then idea again, no, we had the previous setup like this. Now, if meter ruler can be balanced with its weight itself with this, right? It is easily doable, no? Right? Now, say one side was that standard mass. One side was this standard mass simple m, right? Then center of gravity of the meter ruler should be on the other side in order to counterbalance this. On the other side in order to counterbalance this, right? Then from here m0 gx, right? And from here mgx. These three are balanced. These two are balanced about this point of. These two are balanced about this point of. Right? So it's how it should be. That's how it should be. Right? Should be clearly marked. Center of gravity of the meter ruler should be clearly marked. Yes, it is marked now. Right? It cannot be on the same side. Right? Otherwise, if that is on the same side, the system is going to collapse, no? Right? So obviously, we know that cannot be on the same side. Right? Otherwise, the system collapse. Right? Should be on the two different sides. Right? If you switch the sides, that's fine. If you switch the sides, it will be fine. It will be fine. Right? Okay. That's it about question 3 also. Right? Any questions? Any questions? Any clarifications needed?